Trying out the latest tools in Web3 security and seeing what works for you, seeing what makes you more effective is a fantastic way to continue to improve as a security engineer. And so today we're going to be doing exactly that. We're going to be checking out a new all-in-one Web3 security platform called Audit Wizard, and we're going to see how effective it is. It's got some pretty cool features, and it's basically supposed to be an integrated environment designed specifically for auditors. So it's got Slither baked right into the UI, as well as a few other really key features and some new interesting things you can do with AI that we're going to have a look at pretty shortly here. So it's essentially an IDE that is basically designed for security researchers by security researchers. And so I'm going to use it today to actually have a look at the Blueberry contest on Sherlock and sort of go through and try to start understanding these contracts live, and we're going to see how effective Audit Wizard is. So I am beyond excited to give this a try and jump in. I haven't really used it too much yet, but of course, before we dive in, my name is Owen, and over a year and a half ago, I founded Guardian Audits, and ever since then, our team's uncovered dozens and dozens and dozens of critical and high vulnerabilities. And my goal with all these videos that I put out is to distill down everything that I've learned along the way and give it to you so that you can ultimately become a much better blockchain engineer, security engineer, whatever it is that you are looking to be in a fraction of the time. Just overcome all of the things that I had to sort of figure out and experience for myself on the way. So without further ado, let us check out Audit Wizard. Okay, so we're here on the Audit Wizard landing page, and we can see it is basically that. It is like an integrated development environment. So it's sort of like an IDE, but it's sort of like an IAE, right? An integrated audit environment. So we've got an actual window for the code here, and then we have all of these tools along the side and stuff like that. So we can see they've got a ton of great features that we'll see. You can just go and grab import code for anywhere from, even I believe, like you can just put in like a contract address and it will just grab it and pop it into the UI. So that's fantastic. And then they also have this really interesting idea of AI sort of being integrated into the environment and helping you become a better auditor and understand systems more quickly using AI. So that's all fantastic. Let's try it out. And so when we first get here, you can see I've messed around a little bit with a few projects on the side here. And what you can do is they have immediately all the live contests from like Sherlock and Code 4 pulled up here that we could just click on and dive right into. And they've also got all of these bounties. It looks like all the bounties right now are from Hats Finance. So what we're going to do is we're going to go ahead and join the Blueberry update. So we can see it literally just immediately just opens up the repo here. And so this is the Sherlock README. I'm going to, first of all, we can just dive in on the side here. Got a really nice UI here. We can dive into the Blueberry core. And so this is, I'm basically going to be live auditing here. We'll see, try and figure out how to use some of these features as we go. But I guess I'm going to start by having a look at the actual README in the Blueberry core. So let's see. I know Blueberry has something to do with positions and stuff like this, but I actually don't know a lot about Blueberry as a project. So let's give it a read here. Blueberry Core V1 is a leveraged yield farming product. Protocol is integrated with an existing lending protocol, Blueberry Money Market. Whenever a user wants to borrow funds on leverage to yield farm, additionally, Blueberry Bank will borrow from the lending protocol. Okay, so we're borrowing from the Blueberry Money Market. There's a wide variety of assets. We've got this idea of spells, which is how the protocol interacts with the end deployment, such as concentrated liquidity vaults, ET vault. Spell functions include deposit, withdraw. Okay, interesting. So we'll see what that looks like. We've got adjustable positions. So users can adjust their existing positions by supplying more assets, borrowing more assets. Okay, yeah, they can change, how much collateral they have, how much size their position has, or repay some debts as long as the collateral, yeah. So as long as they're, above the collateralization ratio, otherwise they'll get liquidated. Okay, great. So we have a Blueberry Bank and we have spells. So the bank stores each position's collateral tokens. And by the way, this is a fantastic README, right? This is fantastic. This is exactly what I like to see. This is the stuff that I want to know when I'm first getting into the system. Just right here, not way too much text, not way too much detail, not going into line by line or any even like necessary specific formulas just yet. Just getting a high level overview of like, look, these are the contracts that matter in the system. We have this idea of spells, just introducing those from a high level. This is fantastic. And then I can see right here, even we've got this component interaction flow. That's perfect. This is exactly how, at least I personally, like to analyze systems. So you get to see, the steps. So this is fantastic. Great job from the Blueberry team. Just want to call that out. This is a great README. But let's see. Okay, so we've got the Blueberry Bank. This is where the position's collateral, lives. So we obviously store stuff in the bank and wrapped NFT tokens. So that's something interesting. It's not just like an ERC 20 token that's just being like deposited into the bank. There's something interesting going on with NFT tokens. And then we've got executing spells. So, so like opening a new position, closing or adjusting an existing position, that's like what a spell is. Okay, so really nothing too complex there. And I guess they have spells for different types of protocols, right? So define how to interact with each external protocol. So I assume you'd have a specific spell for opening a position on Uniswap or something like that. Execute borrow/repay assets by interacting with the bank, which will then interact with the lending protocol. Okay, interesting. So what we're gonna do, I promise we're gonna dive into the actual features here, and we're gonna see how they can help us as we go throughout this audit. Let's go ahead and let's start off by just following the component interaction flow. So I'm gonna read this, and then we will dive into the actual contracts and try to follow this, see how it actually plays out in the code to get a high level understanding of the system first. So we're going to go, so a user calls the Blueberry Bank. They're going to execute to the Blueberry Bank, specifying which spell and function to use. Okay, great. Okay, so a spell seems to really just be a differentiator of which protocol. So you define the spell and then you define the function on the spell. We'll see what that looks like. So deposit using Ichi spell. Okay, Blueberry Bank to spell. Okay, so spell's got to be like their strategy, right? If I'm thinking about this from like a vault strategy pattern, spell seems to be like a strategy. I kind of wish they would just use the word strategy if that's the case, just to make it very easily understandable, compared to existing vault systems. But we'll see. We'll see if there's a specific reason for using spell. Spell may call Blueberry Bank to do borrow funds and do repay debt. So spell may call, okay, so Blueberry Bank calls spell, and then spell may call back, it seems, to do stuff. We'll see. Funders are then sent to spell to execute pool interaction. I don't know exactly what that means. We'll see. Spells to pools. Spells interact with pools, optimally swap before supplying to Uniswap or removing liquidity from the pool and pay back some debts. We'll see exactly what pools they're talking about here. From the pool to pay back some debts. Okay, we'll see. Optionally staking LP tokens. Okay. Spell may put collateral back into Blueberry Bank. If the spell function called is to open a new position, then the LP tokens will be stored in the Blueberry. Okay, got it. So let's start off. Let's go to the Blueberry Bank. So, and we want to find the execute function. So, and the reason they call the execute function is to do this stuff on a spell. So let's find the Blueberry Bank. Here we are, and I believe let's see what kind of macros they have too. So I think obviously we've got Command Shift, or we've got Command F, and so we can search for execute. So here's our execute function here. I think also, let's see, Command Shift F. Okay, so it looks like Command Shift F pulls up just a search of files if I want to look for a function. Okay, so not sure what their macro would be to find, just like grep the entire code base, but usually it's Command Shift F, but it looks like Command Shift F in here is just like if I wanted to find like the Blueberry, if I wanted to find the bank. Yeah, okay, so it looks like it's just searching files. Okay, cool. So in this execute function, let's see. So it executes a specific action on a position. So we provide a position ID. There's got to be some auth around that. There's an address of a spell. So spell is a contract. So it's address of the contract. I'm going to replace spell with strategy just so it makes sense for me. So the strategy, and then we have this arbitrary data. So that's interesting. That's something to look into. So let's see, before I even read this execute function, I do want to try this cool new feature that I believe if we click AI here, I think we can have the AI analyze this whole Blueberry Bank contract and sort of explain it to us. So let's see. So yeah, save time and effort by using AI to explain complex code to you in digestible terms and analyze security threats. This is amazing. I was talking about this a few months ago. And it's so cool to see it actually be done, but this was the actual application of like ChatGPT that I thought might be useful for auditing, which is not necessarily just to find bugs, but to help security researchers understand the code, take, that code and put it into words that are understandable so that security researchers can just understand a system a lot easier and a lot faster. And that honestly will save so much time during the audit process. So I'm really excited to actually see this be implemented. I actually think this is probably an even better application of AI to auditing than just the normal like here's code, find bugs with code. I think this is the real way that LLMs will have an impact. And that's not to say that there's not some merit to catching obvious stuff with LLMs, but let's go ahead and analyze the code and let's see. Oh, it looks like okay. So that is of course this is still in alpha, so not even beta, but of course sometimes contracts might be too big to analyze from the Chat GPT API. So unfortunately, it looks like at least this contract is a little bit too big. So we'll try it out on a smaller one for sure. We'll see how it does. And then let's see if we can chat with AI. I wonder if we'll get the same issue. So this is cool. We've got some questions to select from straight up right out of the gate here. Yeah, this is interesting. That's a great question to have. So which functions change the state? And yeah, of course. So this contract is too big, but definitely this is a really cool like chat interface that they've built right in here as well. But so on a smaller contract, we're definitely going to try this out. I think this is a great question to, even if you don't have an AI assistant like this is a great question to ask yourself. Basically, get a list of the functions that change the state of the contract, and then you can think about each of those functions as like state transitions, right? So exactly, if I just think about these functions in the way that this function impacts these three state variables, well, maybe that overlaps with this function, which impacts one of the same state variables, but and then what's the dichotomy between how those two functions interact, and maybe you can find some interesting stuff by thinking through that perspective. But anyways, so we're gonna exit out. We're definitely gonna try that on maybe one of these spell contracts, but let's see. And maybe we'll ask the AI, is this just a strategy? And we'll get an answer. So let's see. We execute a specific action on a position. Notice this can be used for various operations like we read in the README, adjusting collateral, repaying debt, etc. And then we've got some params. Let's see, I want to know what this data is. It's a payload to pass to the spell for execution. Okay, so I guess depending on what the spell is, we might do something different with the data. But yeah, arbitrary data is always, it seems like, 23% of the time, that's going to lead to some sort of finding. But let's see here. So of course, the spells should be whitelisted. Obviously, we don't want to have like some arbitrary spell contract. Position ID, if it's 0, then this is interesting actually, because so with the data, so actually I assume the data is the thing that's going to determine which action we're taking, like adjusting collateral, are we repaying debt, are we, increasing the size of our position or something like this, right? I'm assuming the data is going to tell us which one of these actions we're doing. So if the position ID is 0, I would expect that you're always this would only happen in the case where you're creating a new position, right? Because all other like mutations of a position, you've got to specify an actual position. right? So there are cases here that don't necessarily line up that we can add a note. It looks like it's actually so completely read only. So I tried to make like a comment there, but it looks like you actually can't make comments. So we will go ahead and add a note. So let's try adding a note here that in the blueberry bank.sol. Oh, I should be putting this in the location. Highlight code to populate this field. Okay, let's see. How do we? Wow, that is cool. Okay, cool. So we just like selected a line. There we go. We've got it. Then let's see. Let's just title it Position ID Edge Cases. Not a great title, but I can't be bothered to think of a better one at the moment. So in the execute function, presumably the data can be data is used to distinguish what type of action we are taking on our position, e.g., create versus add collateral, etc. However, I, at least at this point, I would only expect position ID to be 0. Specifically, see, I'm making all sorts of spelling errors. Okay, specifically when we are creating a position, right? Because I can see, especially the logic in here is consistent with that, where when we provide this position ID, then we're incrementing the next position ID, which I assume is just a monotonically increasing nonce in the state of the Blueberry Bank or something like this. Then yeah. So this right here is literally, quite literally, creating a position, right? So what we've done here is we get the next position ID, we increment this, and then we quite literally initialize something in the positions mapping with an owner of the message.sender. So yeah, it seems, and I mean, we literally don't know anything about the system yet, but just initially it seems odd that you're not also checking that the data, which I assume would determine. We'll see in a second. But so I guess to make this short, TLDR, data says we are adding collateral, but position ID is 0. We make another position, and then also like position ID. Well, I guess, yeah, it's just confusing. We'll have to see how the spells handle that. So if you're adding collateral, presumably you would be adding collateral or like reducing size. That's an even we are reducing size of a position ID. We make another position. Why would you make another position when you're trying to reduce the size? Just a interesting edge case. Maybe it leads to something, maybe it doesn't. So yeah, we're just going to leave that as a note. Normally I would just have that as a comment, but this is actually pretty cool. So we can, that's nice. So you can just open it up like that. If I want to edit it, we can do that. So we're going to save it. Very cool. So I'm guessing if I like came up here, okay. And then if I click on this, all right, I'm not sure if there's a way to like jump to it, but that would be cool if I like clicked on it and it like directly went to this. So that's pretty cool. Like this way we don't like clutter up the code with a ton of our personal notes. Instead, we've got these bookmarks here. So that's great. That's cool. And then let's see. Let's actually understand what this execute function is doing. So if we're doing it the right way and we're not creating position when we provide our actual position ID, then obviously if we provide something that's like it doesn't exist yet, that's bad. If the message.sender adheres our auth for that, then we validate that. So position ID, oh, this is weird. Oh, is this their like reentrancy lock? Oh man, come on guys. Just use open Zeppelin. All right, let's see this. Where's this lock? Function lock. Where does this lock come from? It's okay. I will say it's too bad that I can't command click. That's probably the number one reason why I use IntelliJ is command click, and using like command bracket to like sort of just jump into and out of functions, and also command shift F to grep a whole code base. Of course, like these are features that need to get added, but that will definitely greatly improve the like the experience jumping through the code base. So let's see if we can find this lock function here. So I'm assuming it's coming from let's see, we've got ensure approve. Okay, Okay, here we go. We've got all this like we have not entered. Then we've got all these like constants. Why is there oh, here's lock. Okay, it was in here the whole time. Okay, great. Okay, so general lock not equal to not, yeah, why you guys got to implement your own? Just use. So I was actually thinking that they would be deriving this from that one thing. So let's go back to our function execute position ID. So why are we setting this position ID like this? And okay, great. So what is this used for? We're setting it and then we're unsetting it. Oh, this is kind of interesting. So this is let me go to the top. Temporary position ID currently under execution. I've actually not really seen this pattern before, so this is interesting. So in exec, so let's see why this is necessary. Ensure that the function is called from within the execution scope. Interesting. So if the position ID is the no ID, not in exec. Okay. So I guess this just constricts the in exec functions to basically say like, hey, we expect these invariants to hold whenever we call these functions. So that is kind of cool. If ever any of those invariants are not true, then usually something wrong is happening. Somebody's trying to manipulate your system. So yeah, I'm a fan of this actually. I hadn't seen anything like that necessarily before, but let's see. Okay, great. So position ID spell, and then we're doing spell.call, and we're just giving it the straight up data. Okay, and the spell is trusted. All right, and then if not okay, then we're going to revert and give us the actual error data. Okay, great. So then after we call that spell, we are going to check if it's liquidatable. If it is liquidatable, then we revert. So cool. Before we look at some of these spells, let's check out is liquidatable. So let's find this function is liquidatable. Okay, great. So this is a really simple Boolean get position risk, and I assume that whatever the spell does in its execution is going to change this. So we get position risk if the risk is greater than or equal to the liquidation threshold. So let's get this function. Computes the risk ratio of a specified position. A higher risk ratio implies greater risk associated with the position. Okay, so we've got these position value, debt value, isolated collateral value. Okay, great. So then we're just doing some computation on here. So ultimately, if the debt value minus the position value divided by the collateral value, okay, so that's what the risk is, and then they define a liquidation threshold that defines, okay, if your position value, okay, yeah, so they handle the case here where you're in basically profit, so position value greater than debt value, so you're above water, else if you're below water, then clearly your debt value is greater than your position value. So this amount here is how much you're underwater. So how much you're underwater divided by your collateral is your risk, right? Okay. So if we could go back, and again, this is where I'm going to shill IntelliJ. You can just command left open bracket to go back to where you were. Really would love to see that in here. I think uh, that would make it kind of a no-brainer for me to come over and use it more. Let's see where we were. We were in function execute. Okay, so we covered that. We covered is liquidatable. Okay, so now we want to go and check out some spells. So let's check out a spell. Let's go to, let's see, we've got aura, basic spell. Let's check out the basic spell to get started. Okay, so definitely I want to try this cool AI feature. So let's have this analyze this contract. Okay, awesome. So this contract's not too long. Let's see. So it's just giving us an explanation. This is perfect. This is so cool. So the Solidity code defines a contract named basic spell, which is part of the Blueberry protocol. The contract is used to manage strategies. Strategies is what I said. So strategies for the protocol. Each strategy is associated with a vault where assets are held and has a minimum and maximum position size. Okay, so obviously one thing about AI and LLMs is we can't be 100% sure that this is saying the correct stuff. So that's interesting. Each strategy is associated with a vault where assets are held. I'm guessing, you have multiple strategies associated with the Blueberry Bank. That's what it seems like. It has a minimum and maximum position size. Okay. The contract also defines parameters for opening and closing positions, uses some libraries from OpenZeppelin. It imports other stuff. The contract includes several functions for managing strategies, including adding a new strategy. Really? So we've got within spells, we've got strategies. Okay. So I did not realize it would be like that. Okay, this is interesting. So strategy to vault. This is interesting. So this is not exactly what I was expecting. Okay, let's see. So let's see. Let's continue reading here. The contract includes several functions for managing strategies, including adding new strategies. So I mean the LLM like read of this seems to be pretty great. Like it's actually like really great. Um, I didn't realize that this had like strategies, and then we'll figure out what the vaults is going on here. But okay, adding a new strategy, updating it, strategy's position size, setting some ratios for collateral, functions for managing positions, obviously, validating the current position size and LTV, refunding tokens, cutting a fee from the rewards, and depositing and withdrawing collateral. So yeah, we're gonna ask it in a second here what all the important like execute functions, external functions are in here. And then I wanna see if we can ask it and figure out what are the functions that should be able to be called, because it's interesting you can provide arbitrary data. We'll have to look at all the external functions that could be called and see if any of them shouldn't be able to be called using that arbitrary data. But let's see. The contract includes several security measures, modifiers, great, checks to prevent actions with zero amounts or zero addresses. And then this is so cool. They've even gotten a list here of like, okay, here's some potential stuff to look into. So the contract does not appear to have any access control on the increase and reduce. That should be fine. That's pretty much what they expect. Actually, no, that is interesting. That is interesting because if we go to the increase, so let's see if there actually is no access control. So increase position, here we go. It does look like there's no access control. Interesting, really interesting. So we're just do lend, bank.lend. That is weird, okay. Deposit specified collateral into the bank. So I guess the first thing I'm wondering is, okay, so I'm guessing this contract is only supposed to like frictionally have assets in it. So whenever you call increase position, like, and then we'll see what this do lend. So I mean, I do think that the access control is ultimately fine, but it is definitely a very interesting point here is that anybody can call this increase position function, and whatever happens here in bank.lend, which we'll see, anybody can cause it to happen. So let's see. So that's a great point to bring up. The contract relies on external contracts, such as the bank. If these contracts are not secure, okay, great, yeah. The contract does not validate the addresses of tokens passed to its function. If a function is called with an incorrect token address, it could lead to loss of funds. Yeah, also, there could be some edge cases around well, first of all, if it's an arbitrary token, if we call a malicious token, or if we call something, if it's open to any token, then of course you got to worry about fee on transfer, rebase, ERC777, straight up an address that doesn't even have a contract at it, which would just return like true success if you tried to call it. So let's see. Contract does not check for potential integer overflow or underflow errors. Maybe outdated a little bit, given the Solidity version, unless, yeah, I mean, there's always the potential for maybe like a panic revert to cause a DOS or something like this, but we'll see. Number 5, the contract does not have a function to pause operations in case of an emergency. Fair point. The contract does not have a function to update the addresses of the bank and this stuff. And if there'd be, okay. So a few great points, a few decent points, but I think overall, like, this is a really cool feature to have like an AI assistant analyze some stuff and then tell you even like here are like 6 different things to look into. That's fantastic. And I think even especially for new people coming on, like if you can't wrap your head around a contract, this one's not too complex, but if there's a super complicated contract you're looking at, I can't think of a better way to be able to start to get a really good feedback loop and like start to get your understanding really cemented by having literally an AI that actually seems pretty good at breaking this contract down, to be able to talk to. So let's go ahead and let's chat with it. So yeah, I'm interested in this. What functions change the state of the contract? So the functions that change the state of the contract, great. It's just listing it. So let's see. We've got basic spell init. So like obviously we've got initializer. Okay, great. I mean, it's doing literally all of them. So yeah, this would be great if you're doing a really in-depth review and you want to get another perspective. You've already done manual analysis, gone through, you understand the system. You want to just think about the system differently to be able to, have a fresh mind, a new perspective. Great way, just like, hey, can you list all of the functions that actually perform mutations on the contract state? Now, start to think about it differently. You could think about it like a Venn diagram. Maybe you could even ask this thing to to create you like a diagram of where these functions overlap and see how calling one function will execute the subsequent execution of a different function or something like this. So that's really cool. I think what are all the external functions that should be called in this contract? Now I'm going to do something important here. I'm going to ask it about the context of, something that what we're interfacing with this contract from the Blueberry Bank. So I don't know if it has the context of the Blueberry Bank. I don't think it does. I think it just reads this contract that we're looking at right now. Of course, the Blueberry Bank is too big, but let's see how it does when I ask it a broader question about the higher level like system workings, and let's see how it does. So what are the extra functions that should be called in this contract from the Blueberry Bank as a part of the Blueberry Bank execute function? External functions that should be called in this contract from the Blueberry Bank as a part of the Blueberry Bank execute function. Okay, set position size. I mean, that might be true. I don't know. I don't know if it's true. It looks like it could be, but of course, that's what these LLMs are great at doing. So let's have a look. Let's have a look at these functions. So set position size. Okay, so update the position size for a specific strategy. I do believe that this should be called from the Blueberry Bank. Existing strategy. Okay, yeah, there's something interesting going on with strategies here. So you give a strategy ID. Ah, okay, I see. So yeah, there is definitely something interesting going on here. So when I do a strategy ID, okay, so yeah, so I assume this is something that points to like a Uni v3 strategy, maybe something like this. And then, okay, so we've got validations, and then we're setting in this strategy's mapping the min position size, max position size. Oh, this is interesting. Oh, this is literally an only owner function. Right, okay. So this is like configuration on a per strategy level. So I don't think the owner definitely shouldn't be the Blueberry Bank. Okay, so the LLM is wrong in this first case here. This probably shouldn't be called from the Blueberry Bank. Let's see the set collateral max LTVs, also only owner. Okay, so let's see if can we go 2 for 4 here. So increase position, okay, right here, and then do lend. Yes, I think this one is intended, like this one's just straight up external. So we go to do lend. So I want to understand this function a little bit. So when we call into this, so increase position with the token and amount. So let's go back to the Blueberry Bank, see where this gets called into again. So as a reminder, we start in this execute function, give it a position ID, a spell, some data, then we call it with this data, these bytes. So let's say this is our spell and we are on increase. So let me find this function increase position. So our data would have like the encoded token and amount here, and then we would do lend with the token and the amount. So it says deposit isolated collaterals on the Blueberry money market. So this is where we're interacting with the money market here. So do lend and bank.lend. And so the bank here is probably set in constructor and is probably that's the money market, right? Reference to the bank contract interface. And yeah, so let's see, let's just have a look at iBank. Okay, so we've got some structs. What kind of functions? View functions, get that value, get position value. So this is telling you stuff about, so lend, this is interesting, deposits token into the bank as a lender, and then you can withdraw. Now you can also borrow and repay. So borrows tokens against the collateral, and you're borrowing from the bank. So it's almost like this is like sort of a manager of your position, a managing layer over the bank, which is exactly kind of what they're saying in the README. So then what do we do? Okay, so if I go back to this increase position, so when we do lend, we literally just bank.lend, and so I don't think, so let's see, the bank, yeah, so we're going to treat the bank as, it wouldn't be this, right? Actually, would it? Yeah, it is. Okay. Okay, so the Blueberry Bank then takes this token and this amount and in exec. So yeah, that's yeah, I kind of see why they're doing this now. Like you can't just straight up call this. So you've got to be like as, so it's kind of a weird call structure, right? You first you call into the bank, then you go into the spell, and then you go back into the bank to do this lending. So okay, then we're getting the position. There's a bunch of banks for, okay, so there's a specific bank for the token, and let's see, ERC20 upgradable, so a token, an upgradable token. Okay, so we're grabbing the tokens, getting them into this bank straight from the position owner. So there, it seems like funds are never actually going into the spell, which makes sense. We're just grabbing them straight from the owner. And then what we're doing is doing some fee stuff, and then we are depositing into soft vault, hard vault. That is an interesting nomenclature there. Okay, and so the vault shares are being stored on the position here. Okay, and so obviously ERC or tokens that have like a fee on transfer or anything like this, probably out of scope. If we go to the Sherlock README, it's probably out of scope, but they're not compatible with the system. And I just want to try out this like findings feature. So let's add a finding that just says that these basically ERC 7, sorry, not 777, fee on transfer tokens are not going to be compatible. We can see you transfer from the owner to this, transfer from the amount. You might not actually get the amount, but we're doing logic with the exact amount. We're trying to deposit that amount here. So let's add a finding. So fee on transfer tokens. We'll just keep that as low, and then great. So it's already got the highlighted lines here. So that's really cool. And then I'm just going to try to leverage AI with this one. So let's say fee on transfer tokens don't work well with the system. Kind of just a really half-assed description. Let's see what AI does. Okay, tokens with transfer fees are not fully compatible with the current system. All right, fair enough. Let's try something a little more interesting. So in the Blueberry bank dot lend function, so it's an arbitrary token. It's an arbitrary token of poke. So that's interesting. They're probably trying to see if it's a real contract, something like that. Blueberry bank dot lend function. The arbitrary token is, let's say, amount. The specified amount of the arbitrary token is transferred into the bank and then subsequently deposited into the vault. I don't really know what the vault is. I just know that it's another contract. So, and there's a soft and there's a hard vault. Okay. So in the Blueberry Bank .lend function, the specified amount of the arbitrary token is transferred into the bank and then subsequently deposited into the vault. However, the actual amount of the token received might not be equivalent to the specified amount for fee on transfer tokens, therefore invalidating the system accounting and recommendation. If fee on transfer tokens should be supported, implement before and after balance checks to see how much of the token was actually received. Otherwise, document that fee on transfer tokens are explicitly incompatible with the system, which I'm sure they already have, but I want to see how the AI rewrites this. So let's see. So rewrite with AI, let's see what it does. All right, cool. So we've gotten a completely AI rewritten version. So let's see. In the Blueberry Bank .lend function, the designated token amount is transferred to the bank and subsequently deposited into the vault. However, there may be discrepancies between the actual and specified token amounts for fee on transfer tokens, which could compromise the system's accounting integrity. And the recommendation, the AI's recommendation to accommodate fee on transfer tokens, we suggest implementing, so me and the AI, we both suggest implementing balance checks before and after the transaction to accurately determine the received token amount. Alternatively, if these tokens are not supported, it should be explicitly documented that the system is incompatible with fee on transfer tokens. So essentially, the same thing I wrote, just a little bit, maybe a little bit more spice, a little bit more gusto added to it. But let me know. Do you like my description, or do you like the AI's rewritten description? But okay. So there's a separate recommendation. So what I'll do is we'll take this, we'll put this here, and then we will just add this finding. And so the coolest part about this is that I don't have to leave the actual, like, the code where the code is. I don't have to leave, I don't have to switch, go to the next screen or anything like this to actually get my finding like written and documented. What I think would be even cooler is if, like, I love it being directly in the code. You don't have to go anywhere else. Um, but it would be really cool to see if I created something here and then it automatically like sent like a webhook to Discord, just because when I'm working with a team, we like to have like a channel where we have all of our threads. Just open a thread for a new finding, and then people can comment on it, add ideas to it, help it become more critical or something like this. And it also just gives, more like a community aspect to uh, the audit, more teamwork centered aspect to it. So I think it would be really, really cool if I just opened a finding on here and it just automatically sent a webhook and opened a thread. I don't even have to open Discord. But I really, really do like that it's actually right here, because oftentimes I'll get something, I want to open a thread for it, but then I have to open Discord. And then, you've got like a ton of messages on Discord. You just get distracted when you were previously in the zone auditing. So I really do like that it's right here in the UI. So, and then an even cooler thing is I think we're able to just auto generate a report because it's in here. So let's check this out. Okay, so we've got all this stuff we can upload, like a let's see if I can find, go to, okay, cool. So I've uploaded, this is an official Guardian audit here. So we've got one low in stark comparison to most of our reports if you go and check them out. Let's see. Okay, so there's like an audit type, timeline, EVM, languages. Great, cool, cool. So we've got our finding, and let's see. So we've got, so let's say Owen for blueberry on this date. and let's generate the report. Let's see. So this, first of all, this is huge. This is huge for a lot of you guys because I know I'm not the only one who spends like an entire day, an entire weekend on reports. So this is huge. Okay, so we've got a report here. Let's check it out. Okay, so here's our security audit. We've got our Guardian logo here. We've got Blueberry. This was prepared using the Audit Wizard, a leading tool in blockchain security analysis. We've got an executive summary, description. Oh, nice. Okay. So we've got like a summary. We've got one low. I like that. This is cool. So we've got okay, findings. All right. And then it just automatically puts your findings there. So this is a huge feature. Honestly, this will save so much time if you could, and even if you could sort of customize this by uploading like your own template, I think that would be so cool. But this is, especially, you know, if you're a solo auditor, you probably find yourself spending a lot of time on reports. This is really cool, the fact that you can just build up the findings along the way and then end up with a full report. So that is really cool. Let's see if there are any final features here. So just go to this arbitrary contract. Let's see. So we've got our notes. We've done AI. So let's try an asked. So of course, if you just so happen to audit based on the asked, that is here for you. I personally don't do it, but that is here for you. And then of course it looks like, yeah, we can generate some nice graphs using probably Surya. And so let's see, yeah, you can also do like a contract scope, and yeah, that is awesome. So, and then scan, I think, so obviously the Mithril and Pyrometer are coming soon. There is Slither, although I think it might be not working just yet, as we're still in the alpha. But yeah, right now we're just getting some null findings. But that will be super cool if you can just run Slither in here. And I'm even more bullish on them adding new stuff like even, so of course we've got Pyrometer and Mithril, but even adding like something like, it would be very cool to see like writing like, oh, write your echidna invariants, or you know, make like an echidna test test harness for echidna in here, and you can just run echidna and it will just run in the cloud or something like that. Crazy idea. Maybe that's something that is planned, but I think that would be really cool for something like this. Okay, so that is basically the Audit Wizard platform. Let me know what you guys thought about it in the comments below. I actually think that there's a lot of potential here. I think that, you know, there's a chance if they keep adding some really cool features and get some of the navigation. I think honestly this might be something that I find myself using a lot more regularly to do some audits, especially with the findings stuff that's just built right in, and a lot of the AI tools. That was very cool. Like, I think from now on, when I dive out of Audit Wizard and I'm looking at a contract, I'm gonna get lazy. I'm gonna be like, man, I wish this was in Audit Wizard so I could just ask the AI, talk to the AI about this. I think that's probably the coolest feature thus far, and I actually think that that's probably the best application of LLMs at this point in time. So definitely go and try out Audit Wizard for yourself and let me know what you think of it. Well, I'll go ahead and include the link to their website down in the description. And yeah, let me know. I want to know if it doesn't make it more efficient for you. Does it make auditing more enjoyable for you? I think that definitely there are some points to improve on. And of course, they're literally only in their alpha, so this is an extremely impressive product to have literally in their alpha. Like, I don't think they've been working on it for too long at this point. So really excited to have such a great product already. I think once they start to add some more features like the code navigation and stuff like that, it's going to be a really heavy hitter. All right, and of course, if you're part of a team that is building a new innovative DeFi protocol and you're starting to think about the security review process, then I want to hear about your project. In fact, I want to hear about it so much that I'll actually go ahead and do a completely free initial first pass security notes on any glaring issues, informational findings, or anything like this that ought to get fixed before you go into an audit when you go ahead and submit a quote at guardianaudits.com/quote. And of course, if you happen to know anybody who is looking for a security review, then of course, send them to guardianaudits.com/quote. And last but certainly not least, if you're looking to join a community of like-minded auditors, people around the world who are also interested in Web3 security, and you might also like the opportunity to team up with others and produce a real audit report as a part of a contest for a real protocol and even get rewarded for your findings, then go ahead and apply to join our completely free community at lab.guardianaudits.com. All right, that is all for this time. I'll see you in the next one.